So good afternoon, everyone.
Good afternoon, sir.
So today we will see the methods which is known as a variance reduction technique. So practical is based on variance reduction technique. So where these variance reduction techniques are useful. So we know that when we have applied the Monte Carlo simulation, we say that the value of n increasing infinite, the variance of the Monte Carlo estimators is reducing with the rate of n raised to minus half, and that conversion rate is considered to be a slope. So now we are looking for the estimate of a theta. Okay, theta is nothing but integration of hx dx in our usual notation, because we wish to approximate the value of integration. We call them as a theta. So we wish to obtain the estimate of a theta in a such a way that it has the lower the standard errors. And whenever you are looking for the reducing the standard errors, it is as good as that you are looking for the reduction of a variance. So there are various techniques are available in the variance reduction. Out of this, we will mainly focus on three techniques: antithetic variables, second one is control variable, control variables, or you can say that it is a control variant technique. And third is importance sampling technique. Third one is important sampling techniques. So we will take one example, and using that example, first I will evaluate the Monte Carlo integration value. We will find out their standard errors, and then we will introduce the concept of a antithetic variables. What is the use of that, and how it can reduce the variance of a Monte Carlo estimators. And then later on we will introduce another technique which is known as the control variant techniques, which can also useful to reduce the variance of the integration. And then last we will talk about the important sampling methods. So ultimate our aim in Monte Carlo integration is that why we go for the Monte Carlo integration, because our aim is that we wish to integrate a complex function. So of course, whenever you wish to integrate the complex function, what is your aim? That whatever the estimate of that complex integration is with you based on the certain technique, that is very close to its true value. And when you say that when it is very close to its true value, it means that the variance is the lesser. That means whatever the estimate you can obtain, it is a efficient estimator. And we know that when you say that estimator is efficient, an estimator which has the lower variance among the class of all estimators, we call them as a efficient estimator. So that means ultimately we are looking for the can we have any techniques which can reduce the variance of a estimate of that complex regression? If yes, so that estimator is really a close to true value, and it is giving the better integral approximation of our complex function. Okay, so we will start with one example. This example: estimate integration over 1 to 3 e raised to minus x square dx, and find 95% confidence interval for that. That integral. So our aim is that we wish to integrate e raised to minus x square over the range 1 to 3. So first we integrate this integral by using the Monte Carlo approach, and we will use the Monte Carlo approach. There are two different ways we integrate using the Monte Carlo integration approach. So first we will discuss about integration using Monte Carlo integration. So we know that how to integrate this. If we are given 1 to 3, that is if we have given a to b fx dx, here we used instead of fx notation dx gx, then we try to find out integration in this way: a to b gx, हमने जो px लिया था उसको हम यहाँ पे fx dx कहता हूँ, where fx is probability density function over range a to b. So if I'm considering fx as the uniform, so my aim is that here I'm saying that fx is a uniform fx is equal to 1 upon b minus a, okay, where x is lies between a to b. It means I can write this as a 1 upon b minus a to b, gx dx. So that is nothing but, okay. So if I'm writing here 1 minus b, so what happen? I have to multiply with this b minus a. So can I write this integration if I'm considering this a to b gx dx gx fx dx. Fx is 1 minus 1 upon b minus a, that is cancel out, it is giving the same, and it is nothing but expectation of gx over fx. Okay, so this is where you can find out the expectation of gx, and if we call them as a theta, then theta cap is nothing but 1 upon n summation I running from 1 to n g of xi, where xi is taken from uniform a to b, because this is, we call them as a fx. So xi is from uniform a to b. So this is called the Monte Carlo integration. So what is the first step? First you have to, how you can find out the theta cap estimate? So algorithm, step 1, generate n uniform variate xi from uniform a to b. Second step is calculate theta mc is equal to, what is the theta mc? It is 1 upon n summation g of xi is equal to 1 upon n. What is g? In our setup, g is equal to e raised to minus x square. It is summation I running from 1 to n e raised to minus xi square, where a equal to 1 and b equal to 3. Step 3, you can calculate this variance. So how will you calculate the variance or the standard errors of theta cap? The standard errors of theta cap mc is nothing but, we know that it is a variance of square root of variance of theta cap mc, and this we already know that it is a s square upon n. So in other way we can also write it as a variance of, because theta cap mc, it is nothing but the variance of gx. If expectation of gx is equal to theta, so we are interested to find out the variance of gx, and where s equal to, where s square equal to 1 upon n minus 1 summation I running from 1 to n g of xi minus theta cap mc whole square. Okay, so so that means we will calculate standard errors of theta cap MC is equal to square root upon s upon n, where s is equal to 1 upon n minus 1 summation g of xi minus theta cap mc whole square I running from 1 to n. And then we wish to find out the confidence interval. Step 5, 4, 95% confidence interval of theta cap mc is theta mc is theta cap mc minus, this is the lower limit, z alpha by 2 into standard error of theta mc cap, and upper limit is theta cap mc plus z alpha by 2 standard error of theta cap mc, where z alpha by 2 is alpha by 2th percentile of standard normal distribution. Okay, so this is the one method. So can we try to solve this using our language? So these are the steps. Any questions in these steps? So let us go to the R. Integrate e raised to minus x square in the range 1 to 3 using uniform distribution as PDF in Monte Carlo integration. Okay. So what is the approach? So last we have seen that whenever we wish to solve, first we define the functions, okay, and after defining the functions we generate the random and then we can proceed. So let us take n equal to 100. X you have to generate R unit. How many? N. What is the range? It is a comma B. But what is the A? A is equal to 1 and B is equal to 3. And after generating this, so before that you have to give the function. Function you say G is equal to, because we wish to evaluate G, it is of function X and the function name is a e power minus x square. That is same function we wish to evaluate, e power minus x square. So after this, what is our approach? We develop the theta dot mc as What is the? It is a sum of. Okay. Let us, we don't directly go. We will first define the x. What is x? So x is nothing but we know that it is a b minus a. Sorry, it is uniform. X is already with us. It is a x is uniform. So what we do? We define the y. Y is nothing but what we are looking y. क्या करेंगे? हमने आपको बताया था ना कि this should be x is uniform, but here, yes, there is a small mistake here. You have to multiply with the b minus c, na? Why? Because you are using the b minus a. Because you are using the uniform. You can see the earlier slide. It is a b minus a of this, and b minus a. So this is nothing but the summation of this. So here I am missing the b minus a. Okay. So it is a b minus a. We will not directly go for the calculation summation. First we calculate the exponent of, this is not the e, this is the exponent. Is it necessary to go for exponent? यहाँ पे लिखने की जरूरत है मुझे? नहीं है. तो मुझे तो सिर्फ क्या करना है, x से मल्टीप्लाई करना है ना, because x I have already taken. It is a, I am generating uniform, and sorry, then I have to multiply with the g of x. Okay, because g is a this function and x is this, it will calculate e raised to minus x square. तो ये y आ गया, तो मुझे क्या मिलेगा? Mean. So if I am saying that, let us say mu1 equal to mean of y. Okay, and standard error मुझे निकालना है, तो मेरे पास डायरेक्ट फंक्शन है standard deviation divided by sqrt of n, square root of n. So it is giving me the standard error of method 1. And then if I wish to find out the confidence interval, even I can use direct con, but I am using this C of lower bound is estimate minus z alpha by 2. So how will you calculate the z alpha by 2? So here you can also give the alpha. Alpha equal to 0.05. Okay. So it is a Q norm. We will verify. Q norm 0.05. What is that answer? It is this. And when I am saying that d, it is divided by 2. What is it? Is a minus 0.196. So it is a Q norm. ठीक है, अल्फा बाई 2. लेकिन ये क्या हो जाएगा, एब्सोल्यूट लेना पड़ेगा ना, z alpha by 2, it is a 1.96, so this should be a absolute value, comma, into standard error is there, yes, into standard error. So standard error you have assigned them as a SE1. Now you wish to assign the upper bound, then what is the upper bound? It is a mu1 plus absolute value of Q norm. So I can also define here. If you don't want to do that, so you can also write z alpha by 2 is equal to q norm. What is that? It is a alpha by 2, and I am trying to take their absolute value, so it is a ABS. We'll verify what happened. We say alpha equal to 0.05. Then what is the z alpha by 2? It is 1.9. Okay. Now instead of, because otherwise become the more complicated. So what I do, I'll just remove this. I'll write z alpha by 2. And then it is a plus z alpha by 2 into standard error. I think this is giving the confidence interval using the first method. This is giving the standard errors using first method, and this is the estimate of integration using the first method. So it is saying that non-numeric argument. Why?
GX डिफाइंड है
हम्म
GX में सर
एक्स नहीं आया है क्या? हाँ, यहाँ पे एन नहीं दिया ना, एक्स ही नहीं आया तो फिर कहाँ से होगा? Now it is fine. क्या बता रहे हैं? G is a function ना, it should work.
सर GX की जगह अगर हम लोग G ले रहे हैं तो G के अंदर फंक्शन स्टोर हो रहा है ना
हाँ, G के अंदर शोर हो रहा है,
yes.
तो वो तो आना चाहिए ना आंसर. G of 2. Why? अच्छा, this is not. स्टेप ज्यादा दे दिया. Okay, now it is giving the answer. You can see this x, this is of gx, this is of y. Okay, so this is the mean. This is the value of mean, and this is the standard deviation. Sorry, standard errors. Z alpha by 2, and this is giving the confidence bound. Okay, you can see that the estimate is lies between. What is the estimate? It is a 0.15, and it lies between this confidence interval. That means it is correct. So now, whenever we apply the another methods, what we try to see that this quantity should be reduced. So when it is reduced, it means that the whatever the variance reduction methods you had applied, it is working well. Okay. But ultimate our as a statistician, our aim is that we wish to reduce the variance so that we can have a precise estimate. Okay. Now let us go with the another techniques. Here we have used the concept of uniform distribution. But if we try to calculate the using the second method. Again, it is a Monte Carlo, but second approach. What is the second approach? So suppose if I wish to evaluate this integrand 1 to 3 e raised to minus x square dx. Suppose can I write in this way? Suppose if I am multiplying this with the root pi, root pi 1 upon root pi e raised to minus x square. Can we write? Yes or no?
Yes, sir.
Okay. So if I am saying that I am deciding I am also adding one indicator variable 1 to 3 root pi into indicator variable that 1 3x, that is I 1 3 x takes value 1 if 1 less than x less than 3, 0 otherwise. कर सकते हैं ना? Am I right?
Yes.
ठीक है, क्योंकि यहाँ पे 1 है तब ये पार्ट आएगा, 0 है तो यहाँ पे दिस पार्ट विल बी वेनिश. मतलब it takes value always 1 because you are in the range 1 to 3. Okay. So suppose if I'm saying that this is a normal density, can we say it is a normal density? This quantity. What is the distribution? This is nothing but normal with mean 0 and variance क्या होगा? 1 लेंगे तो यहाँ पे √2 पाई सिग्मा आता है ना, तो यहाँ पे √2 है, ये सिग्मा है, तो ये √2 और सिग्मा कैंसिल हो, तो आई हैव टू गिव सिग्मा इक्वल टू 1 अपॉन √2. सही है ना? बिकॉज नॉर्मल डेंसिटी इज है 1 अपॉन √2 पाई सिग्मा. So √2 is not showing here. Sigma is, if I'm taking 1, then this is mistake. So what I do, I say that it is a normal 0, 1 upon √2. So that sigma is 1 upon √2. Here it is a √2, so that is cancel out. And here it is a 1 by 2 sigma square. So 1 by 2 into sigma square is 1 upon √2 square is 1 by 2. So 1 by 2 cancel out. It is a e raised to minus x. So this is my normal density. So that means It is actually, if you talk about, this is nothing but my gx fx dx. What is gx? It is a root 2 pi I13. So you have to generate a random numbers from a which PDF fx, and then you have to evaluate the function this. So that means it is a expectation of gx over fx.
हेलो
And
सर,
yes,
हमारी रेंज 1 to 3 है ना?
yes,
तो
1 2 3. Sorry, 1 2 3, 1 2 3. Okay. तो यहाँ पे इसका अर्थ क्या हुआ? तो आप बोलेंगे सर यहाँ तो रेंज 1 to 3 है, and हमने तो नॉर्मल में तो माइनस इन्फिनिटी इन्फिनिटी ले रहे हैं. बट वी से दैट normal is from we are generating from minus infinity to infinity. But which variable we are considering? A value which is lies between 1 to 3. Okay, so that is how we are using the indicator variables. And it is as good as you can say it is a expectation of fx, that is x, over what is your gx? Gx is root pi I 1 comma 3 x. One comma three. Okay, so it is as good as that. You have to generate the estimate this theta. So theta cap Monte Carlo is nothing but 1 upon n summation I running from 1 to n g of xi. That means it is a summation I running from 1 to n. Root pi is outside. This is divided by n. You have to take the value of, if xi lies between 1 to 3, you take 1, otherwise it is a 0. So this is. And variance. So variance is nothing but the same formula which we have discussed. It is s square is equal to 1 upon n minus 1 summation I running from 1 to n g of xi minus theta cap mc whole square, and standard errors of theta cap mc is nothing but s upon theta. Okay, and confidence intervals formula is also the same. That is nothing but confidence 91 minus alpha percentage confidence interval of theta is, so it is a theta cap mc plus or minus z alpha by 2 into standard errors. So what is the algorithm? Anyone? So what is the step 1? Generate n random number, say x, from normal 0 1 upon root 2. Then क्या करेंगे? What you do? Calculate theta cap mc is equal to summation I running from 1 to n root pi upon n. It is a indicator variable 1 3 of x. Okay, that is if xi is lies between 1 to 3, then I13 xi is 0, sorry 1, 0 otherwise. It takes 0 otherwise. Okay. Step 3, evaluate standard errors of theta cap and c. Fourth, calculate 95% confidence interval of theta, that is theta cap mc plus or minus z alpha by 2 standard error, and print the output. Okay, this approach we have already used in the indicator variables, the same. So how we write the program? We wish to integrate this using normal, which means 0 and 1 upon sqrt of 2, square root of 2. Okay. In Monte Carlo, तो व्हाट वी डू, यहाँ पे हमें फंक्शन डिफाइन करने की ज़रूरत है नहीं है, क्योंकि हमें डायरेक्टली नॉर्मल से ही जनरेट करना है ना, क्योंकि वी हैव टू जस्ट यूज द इंडिकेटर वेरिएबल्स. लास्ट में हमने अप्रोच ऐसे यूज किया था, असाइन द 1 अदरवाइज 0, इफ यू रिमेंबर somewhere we had applied this. If x less than t, return the 1 as return 0. This ways you can also write, or I will show you another way. In that way you can also write. It is up to you. Choice is yours. So n, I wish to, let us say, generate the 100. So x is nothing but I know that I have to generate the x from normal 0, 1 upon root 2. So r norm. How many n I wish to generate? What is the mean? 0. What is the variance? 1 upon sqrt of 2. Okay. So x generate हो गए, तो now I have to generate the y. Y is nothing but how should I generate the y? This is actually my y. Root pi into I13 xi. This is what we call the y. And it is nothing but theta cap mc is equal to summation yi upon n, where yi equal to root pi into this. Okay. So y is nothing but sqrt of pi into, you have to check. So what is the output here? it is giving the integer value. It takes value 1 or 0. So s dot integer x is less than 3, or you can also add equal to. There is no issue because we are allowing both. And x is greater than or equal to 1. Okay. So this is y is generated. So what is now? You wish to find out the real side mu 1, mu 1, mu 2. That means mean. Mean is nothing but mean of y. Then SC2 is nothing but SQRT of, sorry, it is a SD of y divided by SQRT of n, and confidence interval is same as. So I'm just z alpha by 2. What is z alpha by 2? It is a q ABS of q norm 0.0, that is alpha. Here I am giving the alpha to 0.05. Now confidence interval is equal to, this is I am saying CI2. I think I have given CI1, yes. C of mu2 minus z alpha by 2 into AC2 and comma mu2 plus z alpha by 2 into AC2. Let us check. Mu is 0.03, AC2 is 0.01, and CI2 is this. So is it correct, or have we made any mistake? Suppose if I am giving the print as a y, let me show you if I am taking only 10 observations so that you can easily verify. These are I have generated x from let me give the only y. Verify.
सर वहाँ पे अल्फा बाई 2 आएगा क्या?
Yes, alpha by 2 आएगा. मैंने कहा ये रेंज छोटी क्यों हो गई? So you can see this value. This is the value of x which we have taken from normal distribution with mean 0, and standard deviation is 1 upon root 2, or variance you can say 1 by 2. Then I am trying to find out, let us if I am trying to see that the first observation is less than 3 and greater than 1, तो यहाँ पे 1 आएगा. यहाँ पे you can get the 0. Why? Because it is a minus. So let us try to see. Sorry, it is not greater than 1. and less than 3 but not greater than 1, so it is 0. This is the minus. This is also 0, but this is greater than 1 and less than 3, so it has taken 1 here. And this is not greater than 1, so it is a 0. Okay, so after getting this, you can calculate the y. This is your y, and then you can find out the mean. This is your mean. And so correct, alpha by 2 की जगह पे alpha लिखा था. So this is the estimate of the theta. But now if we increase the, let us say n equal to 100, then what happens? अभी भी जवाब बहुत कम आ रहा है. Answer is very low because it should be nearby. सेम आंसर आना चाहिए ना. यहाँ पे कितना है? μ1 कितना था? μ1 एंड μ2 की वैल्यू आसपास से आनी चाहिए ना. This was μ1 and here μ2 is very low. तो कुछ मिस्टेक है अपनी. What are the mistakes? Can you observe any mistake in this? In earlier example, in the last lectures or practicals, we have declared the function this, and then if x is less than and greater than 1, we assign them as a 1, otherwise return 0. So in that way you can also define the function and then you can calculate. Instead of doing that, I have just write here, if this is condition is satisfying, then it takes value 1 and then it should be multiplied with the square root of pi. I was trying generating the 1000. What happened? It is very low. Because I'm not adding equality sign. What happened? It has no connection. Answer should be very close to each other. Why it is not? It is taking normal sigma, na? The normal mean sigma square.
हेलो सर.
Hello.
सर y को रियन से डिवाइड करना.
किससे डिवाइड करना है?
यन से हमारा फॉर्मूला y का.
नहीं, y को नहीं, सम. वो तो मीन में आ गया ना n से डिवाइड करने का.
ओके ओके.
वो तो यहाँ n आ गया. तो कोई प्रॉब्लम नहीं है. Program is all well. There is no issue. Answer is very low. generate n random variable which spines from the normal 1 upon root 2 that we did. Then we have calculated the value of xi, I13. If xi lies between 1 and 3, then we assign it as a 1 and then multiply with the root pi. There is no issue. And then we divide it by n so we can find out the mean. वो भी मिल रहा है हमने बराबर किया है. Is it generating what is the histogram of x? 0 है. वेरिएंस ऑफ x बराबर है 0.5 आ रहा है, क्योंकि 1/2 वो तो बराबर जनरेट कर रहा है. दोनों मेथड में आंसर तो सेम आना चाहिए ना. वेरी लो. Root pi is fine. Anyone would like to add anything? Actually, when you write this indicator, then this becomes from minus infinity. एक इंडिकेटर है इसलिए 1 2 3 की जरूरत नहीं. ठीक है. दिस इज योर माइनस इन्फिनिटी टू. उसमें कोई प्रॉब्लम नहीं है जिस वक्त वो मेरे ध्यान में है. It should be giving the answer. It is giving 0.139. इसका मतलब पहली मेथड से तो आंसर सही है, दूसरी मेथड में गड़बड़ हो रही है. Because exact answer if you find and our new one is that we can improve by just taking the 10,000. you take higher value, it is very close to it. That is fine, but why it is not giving for the second method? It should work, no? Logically, technically, it should give the answer. मैं वही देख रहा हूँ, मैं कहीं गलती कर रहा हूँ प्रोग्राम लिखने में. अच्छा, आया कुछ और. ओ, अच्छा, अब प्रॉब्लम नहीं होगा. आया कुछ और ले रहा था. अगेन आंसर तो सेम आना चाहिए. व्हाई इट इज ओके. इज दैट क्लियर? क्या गलती थी जो हमने पुराने practicals में, in previous practicals we have assigned the pi I, ना, we have taken the various probability. No doubt the pi I is a, by default it is giving the ratio of the circumferences of circle to its diameter. That is true, but here R is taking the pi I as a vector earlier. That's why. So now we are getting the same answer, more or less similar. So that means the approach is same.
सर एक बार
Is that
सर एक
clear?
बार फिर से कोड दिखा दीजिए.
कोड में हमने कोई चेंज नहीं किया है. वी हैव नॉट चेंज एनीथिंग इन ए कोड. मैंने सिर्फ क्या किया, यहाँ पे एक रिमूव लिस्ट करके लिया. तो आई हैव जस्ट इरेज माय प्रीवियस हिस्ट्री. I have just used this command. So always before starting your R, it is advisable. जैसे हम C++ में क्लियर स्क्रीन करते थे ना, रिमूव हिस्ट्री लिस्ट. Nothing is changed. Only we have generated x from a normal distribution, which means 0 and square root standard deviation is 1 upon square root 2. Then we have checked whether the whatever the x is lies between 1 to 3. If yes, it is taking 1. Otherwise, it is taking 0. Then I have multiplied with the square root of pi I, and then I have find out the mean and find out the standard errors and then confidence interval. So you can see the mu1. तो हमने रिमूव ही कर दिया तो mu1 कितना रहेगा. So you have a mu1 is 0.139, mu2 is also 0.138. So you can use this method. You can use this method using the some different approach. We have used the normal instead of the uniform. Is that clear? So it's standard errors of the first method. दोनों मोंटे कार्लो ही है. आप देखो दोनों की स्टैंडर्ड एरर्स में कितना फर्क है. So it is saying that it is better that you should use the uniform method rather than the normal approximation method. Okay?
Yes, sir. Yes, sir.
But we will not actually discussing this. We wish to actually introduce the concept of a variance reduction technique. So now we will slowly and gradually going for the variance reduction technique. So why we use this? To improve integral approximation. So, and how it will improve? If your estimator is if, sorry, if estimator is efficient. So how will you identify estimator is efficient or not? So you know that. Let me introduce again. There is efficiency criteria. If theta 1 cap and theta 2 cap are two estimators, of a parameter theta, then theta 1 cap is more efficient than theta 2 cap if variance of theta 1 cap is less than variance of theta 2 cap. And the amount of reduction amount of reduction in variance is measured by so कैसे तो पहले estimators it is saying that the first is theta 1 theta 2 are the two estimators of parameter theta 1 is more efficient so just subtract the variance of theta 2 cap from variance of theta 1 cap and variance of divided by variance of theta 1 cap. So this is nothing but the amount of reduction. But आपको देखना है which one is efficient जिसका variance कम है जिसका ज्यादा होगा उसका क्या करेंगे आप subtract करेंगे. So these are the small things may ask in MCQ. Viva likewise. So in our setup, if I wish to find out the efficiency, okay, how should we find out efficiency?
हेलो
Yes,
हेलो
yes, बोलिए. Hello, am I audible?
Yes, sir.
तो भाई को क्या प्रॉब्लम है? So the estimated amount of reduction in variance is what is that? तो आपको standard error of 1 square minus standard error of 2 square divided by standard error of 1 square. It is giving minus 5.03. So which one is more efficient? First or second? बताइए किसका वेरिएंस कम है? Of course ये greater than 0 हुआ तो क्या हुआ? If this is greater than 0, less than 0, तो क्या होगा? Variance of theta 2 cap is efficient. ऐसा हुआ ना? क्या हुआ? If this is less than 0, what it means? Variance of theta 1 cap is less than variance of theta 2 cap. That means theta 1 cap is more efficient. Okay, तो नेगेटिव आया अपने सेटअप में तो व्हाट वी से व्हाट इज द इंटरप्रिटेशन variance of 1 is more efficient. Are you getting my point?
Yes, sir.
हाँ तो ये जवाब क्यों नहीं दे रहे हो? Okay, so it is negative, so that we can say that the variance of theta 1, that means the whatever the estimators is obtained based on the first method is more efficient. तो नॉर्मल इंटीग्रेशन से आपको उसको करने की जगह पे कौन सी मेथड अच्छी रहती है? uniform method. Okay. ठीक है. आगे बढ़ते हैं. So this is what we talk about the efficiency criteria. Now we talk about the first technique, variance reduction technique. The technique name is a antithetic variables. So how it works, so let me discuss with you. If x and y are negatively correlated, say these all methods are useful to approximate the integral. Okay, ये ध्यान रखना है. It is not for the generation. X and y are negatively correlated. So negatively correlated means covariance between x comma y is less than 0. Then what is the variance of x plus y? It is a variance of x plus variance of y plus 2 times covariance of xy. But what happened? This is negatively correlated. So can we say that this is less than variance of x plus variance of y? क्योंकि ये नेगेटिव है तो इसमें से क्या हो जाएगा? कम हो जाएगा. So that means this quantity is the higher than this. तो इसका मतलब है कि variance of x plus y is less than variance of x plus variance of y.
Variance of y.
ठीक है. कब? When both variables are negatively correlated. So we have to select the variable. They are negatively correlated. So such variables are called the antithetic variables. So let us talk about the uniform example. This is general statement I have given. If U is standard uniform 0, 1, then what is the distribution of 1 minus U? Anyone? What is the distribution?
स्टैंडर्ड यूनिफॉर्म ही होगा ना.
तो यूनिफॉर्म ही होता है. Good. It is a uniform 0, 1. Okay. So now what is the covariance? Therefore, covariance between U and 1 minus U. What is that? It is a minus covariance of U comma U. And it is nothing but minus variance of U. And what is the variance of standard uniform? We know that if it is lies between A to B, then it is a B minus A whole square divided by 12. But B is 1, A is 0, so it is a 1 by 12. So it is a minus 1 by 12. And which is less than 0. Okay? Is it fine? Any questions up to anyone? So these results are important to understand the calculations are in antithetic variables. What my basically idea is that if I am taking the x and y, both are negatively related. Suppose I am generating 50% random variables from the uniform 0, 1 and 50% from the 1 minus uniform. So their covariance between these two is negative. So what happens if I am taking the sum of these two, it is actually minimizing my variance. So we try to see that aspect, and that is how this property can help you to reduce reduction in the variance. We will continue with the same example. Okay. So we talk about the application of this variable. There are other results are there, but that I'm not going to explain here. If g of x is monotone, okay, ये हम जानते हैं using u1 u2 un is generated from uniform 0 1 to find if G is monotone and we generate a n random number from the uniform to find estimate, that is theta cap MC. It is 1 upon n summation I running from 1 to n G of ui. तो जहाँ x है वहाँ पे आप क्या कह दिया आपने G of ui का, and this is a theta MC is an estimate of theta and what is theta? Theta is nothing but 0 to 1 gx dx. This we know has higher variance than the antithetic estimator. Which is defined as, so if it is antithetic, so we call it is a theta cap A, it stands for the antithetic. It is defined as a 1 upon n summation I running from 1 to n by 2. So हम 50% UI जनरेट करेंगे, हम 50% क्या करेंगे G of 1 minus n. तो ये हमने किया ना, let us say this is x, this is the y. So what we say that the variance of x plus y is actually less than the variance of x plus variance of y. तो इसका मतलब हम आगे प्रूव करेंगे अभी कि variance of theta a cap is less than the actually a variance of theta mc. So that is all I have said. So this is nothing but the antithetic estimator, the form of antithetic estimator. So what we say that variance of theta 1 cap, theta a cap is the higher than the, sorry, is lower than the variance of theta mc cap. It means that theta a cap is more efficient than theta MC cap. क्यों मैंने ऐसा हायर क्यों कहा? थीटा MC cap has the higher variance. The reason is that since variance of theta A cap is equal to variance of, what is the estimate of theta cap A cap? It is 1 by n summation I running from 1 to n by 2 g of ui plus g of 1 minus ui. यही है, because we know that the u and v are these are independent. All which are independent? Which are independent? Uniform random numbers are independent, na? Am I right or not? u1, u2, un are independently distributed. So variance of sum is nothing but the sum of variance, because covariance between ui is 0. So 1 upon n bahar niklega, it is a 1 upon n square. It is summation I running from 1 to n by 2 variance of g of ui plus g of 1 minus ui. Is that fine?
Yes, sir.
Why? Because ui's are independent. See, ui's are independent. ui and 1 minus are not independent. There is a correlation, and that is minus 1 by 12 that we have seen. Okay? Only ui's are independent. So that is how it is a variance of sum of independent variable. It is nothing but the sum of variance of independent variable. Now here, how many? There are n by 2. And because ui's are IID, because it is lies between 0 to 1. So can we write it is a n by 2 time, this is n square. It is a variance of g of ui plus g of 1 minus ui. ui की जगह मैं u लिख देता हूँ. Why? Because they are IID. Because ui's are IID. I running from 1 to n by 2. Okay, so this n cancel out with this. So what you will remain? It is 1 upon 2n. Okay, and this is nothing but the variance of, क्या लिख सकते हैं इसमें? Variance of g of u plus variance of g of 1 minus u plus twice of covariance of g of u, g of 1 minus u. लिख सकते हैं? We can write. Okay. So earlier result, this variance of, because this is the negative covariance between gu and g1 minus u. So we can write this as it is a less than or equal to 1 upon 2n variance of gu plus variance of g1 minus u. Okay. So because the variance of gu or variance of g1 minus u, it is the same variance. It is a twice. It is nothing but less than or equal to variance of gu divided by n, because 2 will be cancelled out. And this is nothing but the actually a variance of theta cap mc. So it is showing that the variance of theta a cap, which is less than or equal to variance of theta mc, theta cap mc. So we say that the aesthetic variable technique, the estimate obtained by or the estimate of the theta obtained by the aesthetic variable technique is more efficient than the Monte Carlo method. Is that fine? Any questions, anyone?
No, sir.
No, sir.
Okay. तो ये हमने आपको प्रूव किया था. अब हम क्या करेंगे? What we do? We try to use this technique. So we try to generate the uniform random numbers and then calculate GU. Then 1 minus UI, then calculate the GU. And दोनों का हम sum करेंगे और उसका यूज करेंगे. तो 50% हम कौन से n/2 जनरेट करेंगे? दैट इज n इक्वल टू 100, तो 50 g ऑफ ui एंड 50 कौन से हो गए? g ऑफ 1 माइनस ui. दोनों का सम करेंगे एंड देन वट एवर दी उसकी एवरेज निकालेंगे. वट एवर द एस्टिमेट वी आर गेटिंग, इट इज नथिंग बट द एस्थेटिक एस्टिमेट ऑफ इंटीग्रल. ठीक है. So again we will come to the same questions. Evaluate zero, 1 2 3 e raised to minus x square dx using antithetic variable technique, and we will show you that it is actually reducing the variance. We will compare the standard errors. So how to evaluate this? So what is the algorithm? First step is generate n/2. क्या करेंगे? बताइए क्या करेंगे? जनरेट n/2 यूनिफॉर्म random numbers ui from 0 1, I running from 1 to n/2. Okay. फिर क्या करेंगे? व्हाट वी डू? अब यहाँ पे हमारा यूनिफॉर्म 1 2 3 है, तो यहाँ पे हम क्या करेंगे? स्टैंडर्ड यूनिफॉर्म की जगह पे यूनिफॉर्म 1 3 कर देंगे, क्योंकि रेंज 1 2 3 है. बाद में उसको b-a से जो हमें करना है वो करना है. देन what we do? Then calculate वन माइनस सी. इसको हम अगर इसका ऐसा है तो इफ वी कॉल दिम एज एक्स एंड दिस को कैन बी कॉल एज वाई. ओके, और इट इज ए, तो जान दो उसको एक्स एंड वाई नहीं करेंगे. थर्ड, combined I equal to 1 to n/2. Combined ui 1 minus ui I equal to 1 to n/2. ओके. तो ये आपका क्या हो गया? फाइनली आपका एक वेरिएबल हो गया, इसको कहते हैं x. तो x is containing, it is a vector of variable which containing u1 u2 un/2 and then 1 minus u1 up to 1 minus un/2. तो टोटल कितने हैं x में? n ऑब्जर्वेशन. देन फोर्थ स्टेप इज calculate y equal to g of x. What is g of x in our case? G of x in our case is b minus a into e raised to minus x square by 2. Sorry, x square, where a equal to 1 and b equal to 3. Why I have taken here b minus a? Because I am generating it from uniform 1 to 3. If it is only 0 to 1 range, then b equal to 1 and a equal to 0. So I have to just gx equal to this. Fifth, calculate theta a cap. तो ऑलरेडी मैंने यहाँ पे सारे ले लिए हैं. 50% ऑब्जर्वेशन यहाँ लिए तो ये मुझे टोटल कितने मिल गए? Total n observation, n by 2 here, n by 2. So I'm not writing 2 times this. I'm just writing that summation I running from 1 to n. अगर gxi कहो इसको, तो this is gxi. इसको यहाँ पे xi कह दो. ठीक है, कंबाइन करना है. तो it is a g of xi upon n. Calculate standard error of theta a cap by s upon root n, where s square equal to 1 upon n minus 1 summation g of xi minus theta a cap whole square, and xi के अंदर भी कितने n ऑब्जर्वेशन है. ओके, तो x एक्चुअली आपका ऐसे हो गया. इफ यू राइटिंग द वेक्टर, इट इज ए u1 u2 un by 2 1 minus u1 up to 1 minus un by 2. So this is your x. Okay, and then you can evaluate the 7 confidence interval. Confidence interval for that is 1 minus alpha into percentage confidence interval for theta is, and what is theta in our setup? In our setup, theta is equal to 1 to 3 e raised to minus x square dx. So we had used the approach. कौन सा अप्रोच यूज किया? अप्रोच तो हमने कौन सा यूनिफॉर्म वाला किया, फर्स्ट वाला, एंड देन वी यूज द वेरिएंस रिडक्शन टेक्निक. ओके, आप सेकेंड अप्रोच से भी कर सकते हैं. इट इज अप टू यू. वहाँ तो एक्स नॉर्मल से कर रहा है, उस हिसाब से जाना है. So that you can, somebody can try in the assignment. There is no issue. Theta cap plus or minus z alpha by 2 standard error of theta a cap. Is that clear? So we know that in antithetic variable techniques, we require the two variables which are negatively correlated. So suppose if I am saying that uniform, then 1 minus u is also a uniform, and covariance between u and 1 minus u is a minus 1 by 12. It is variance of u. So it is a negative correlation. So I will generate n by 2 uniform random variates because I am integrating from 1 to 3. So I am generating uniform from 1 to 3. Then I will calculate the 1 minus ui. Then I am combining both the ui and 1 minus ui for I running from 1 to n2, so that in combine I have a n observations. Then I can use the calculate the gx. So g is nothing but the function e raised to minus x square, but because I am generating from uniform, so it has a b minus a e raised to minus x square, and then I can calculate their average and then standard errors. So let us try to generate using variance reduction technique. antithetic variable. Antithetic variable. And evaluation is from the same integral. So what we do first? First, let us assign the n. We'll take the larger sample size because we know that the as n tends to infinity, n is very large, it converts to the true value consistency property, and alpha equal to 0.05, 95% confidence interval I need. Now I'm defining the g as a function. What is the function? तो फंक्शन के अंदर ही मैं लिख लेता हूँ, इट इज ए x, and x is nothing but p minus a into exponent of minus x square. Okay, I can give a equal to 1, b equal to 3. So this is the function I'm going to use. Now, as I say that I have to generate the x from, or let us say u from our standard uniform. No, we will generate from the 1 to 3. So what is this? What is this? How many generate? 50%, that is n by 2, lower limit a and upper limit b. Then I will calculate the 1 minus u. So u here, comma, I am combining 1 minus u. That means now x contain how many observation? N observation. This has n by 2, 1 minus u having also a n by 2. Okay. Then I will calculate y. Y is nothing but g of x. Okay. And then what I do? I will find out the mu3. Mu3 is nothing but mean of y. And then I will calculate the standard error of aesthetic variable, also not aesthetic, antithetic variable. It is a SD of y divided by SQRT of n. Then Z alpha by 2 is nothing but absolute value of Q norm. Why absolute? Because I need positive value, 0.05 divided by 2. And then I can calculate the confidence interval for 3, that is mu of 3 minus Z alpha by 2, Z alpha by 2 into standard error of 3, comma, mu 3 plus Z alpha by 2 into standard error of 3. Okay, so this is where you have to calculate. So any errors? Any? So let us try to evaluate what is the answer. So is it correct answer? यहाँ पे हमारा 1 माइनस यू, तो यहाँ पे हमें एक काम करना पड़ेगा. वी हैव टू मेक लिटिल चेंज. यहाँ पे 1 माइनस यू लिया है ना, यू तो हमारा क्या है, नेगेटिव हो जाएगा ये, क्योंकि 1 माइनस यू तो गड़बड़ हो जाएगी. तो व्हाट आई डू, आई विल जनरेट फ्रॉम फर्स्ट 0 to 1. तो ये यूनिफॉर्म हो गया. उसके बाद मैं क्या करूंगा, x जो लिख रहा हूं, और x आ गया. अब x में मैं क्या करूंगा, b माइनस ए इंटू क्या करूंगा, वापिस x प्लस 1. क्यों, why I have done this? क्योंकि हमारा fx क्या होगा, fx will be x माइनस ए अपॉन b माइनस ए. fx को हमने क्या कहा है, u. ठीक है, तो वी कैन राइट इट एज ए b माइनस ए into uniform where u is from 0 to 1 plus a, and that is equal to x. So now this x is generated from 1 to 3. Okay, why? Because u is from distributed uniform 0 1, and we show that x is uniform between a to b. So that is how it has given the error. So this is what I have written the same. Now it is correct. Now what is the standard errors? AC3. It is a 0.009. And this is the confidence interval. So AC3. So what is the AC1? हमने कहा था ना AC1 is the better. So you can see that. यहाँ पे कितना है? AC3 is 0.001919 and this is 0.001934. So which has the higher variance? AC1. So we can see that AC3 square minus AC1 square divided by AC3 square. So you can see that there is a reduction in the standard errors. So it is suggesting that the aesthetic variables, not aesthetic, antithetic variable technique is actually reducing the variance of the estimator of the theta. So antithetic variable technique is giving more better approximate result of integral. Is that fine? Does anyone has any questions, doubt? Anyone? Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
No one has doubt. Very good. Everyone understood. So, homework. Evaluate zero to 10 exponent of minus twice of x minus 5 dx using Monte Carlo integration and variance reduction technique antithetic variable. Okay, further obtain, यहाँ ही लिख देता हूँ. Further obtain theta mc cap theta a cap standard error of theta cap mc standard error of theta a cap and 95% confidence interval. हो जाएगा ना? So here you have to use the approach of आपकी मर्जी, दोनों यूज कर सकते हैं. You can use the normal density approach with mean mu. Mu is 5 and sigma is 1. And you can use the uniform distribution approach from 0 to 10. I have no problem. You can use both the approach in a Monte Carlo methods, and then you can also use both. Also use the approach in a an antithetic variable technique, and you have to show that which one has the closer approximation. So you can evaluate, integrate this exponent of minus 2 mod x minus 5 over 0 to 10, you will get the exact answer. So any questions, anyone?